we've had a number of people, SASTAR members, that have asked for a presentation on working satellites. And a number of people that have joined the group said one of their big goals in life is to work the International Space Station or a satellite, move that. So I had tried to make a contact at least 5 years ago, maybe even longer than that, and failed. And so I thought, okay, I'll just put my equipment aside for now. And so I thought at this time I might as well come back to it, see maybe I can figure out what I did wrong, which I think I did. And one of the things is to use a better transceiver than what I had before. And also I found that it was possibly some of the cables I was using were defective, which explains why I didn't hear anything on 440 megahertz. So I've since checked out everything and have a better transceiver. So I think I've got a good chance of doing this, but I haven't actually succeeded yet because I haven't actually tried in the last few weeks while I was putting this together. Okay, so let's see here. A bit of an outline. I'll give you a brief intro to some of the satellites. And this has been going on since basically I was about 4 years old, I think, was when they launched the first satellite. So I wasn't licensed yet, but they've been doing this a long time. And we'll go through a little bit of the what it takes to get started on this, where to find the information, what kind of antennas to use, and how to set things up, and how to actually make the contact through voice. And then Sid has been so kind to actually revisit what he did a couple of years ago and make some contacts through the International Space Station using APRS. So we'll also show you a presentation on that if we have time. If not, we'll do it next month on that. But hopefully I won't take too much time on this. So in the introduction, one of the nice things right now is there's a lot of satellites up there, and you can work people over several thousand kilometers, and you don't have to worry about propagation. Who cares what the sun's doing right now, unless it's a massive storm, and then could be radio blackouts. But in general, you don't worry about that. And the passes are 100% predictable. You can go online, look at how the satellites are moving about, and pick satellites that, or maybe one in particular that you think you've got the best chance of making a contact, and plan it all out. So planning is 99% of it, I think, and making sure that all the boxes are checked and we'll go through the routine here. But the whole thing from start to finish takes somewhere between 10 and 20 minutes at most. Usually they're 10 to 12 minutes or 15 minutes for a pass of the satellite. So you've got to have everything ready, know where to look, know where to point your antenna and so on. And then and hopefully everything will work out. So FM satellites, that means a satellite with an FM or a mode of FM voice, basically works like a repeater that you're familiar with on the Earth, but they're in space. So there's a transmitted signal on one band, is the uplink, and a received signal on usually a different band is the downlink. And most of them require a tone, a PL tone or CTCSS as we call it now, to access the satellite. That prevents a lot of, it helps the satellite with noise issues. So it looks for that tone to be activated and to be accessed. Downlink signals are, a lot of these satellites, less than 1 watt, but because it's line of sight, that's usually plenty. But you do need to have a fairly sensitive receiver to hear these satellites. And basic hardware required for FM satellites. So you want to do voice, either a dual band handy-talkie for 2 meters and 70 centimeters, or 2 separate transceivers. one on each band. If you're doing the one HT with a dual band HT, you'd like a diplexer, so that it separates both. There's two antennas on one 2-in-1 kind of thing, which I'll show you an example of that, the arrow antenna, and so it separates those. It's basically a high pass and a low pass filter for the bands that you're working on. And I've done some my nano VNA tests on my diplexer to see that it actually was working properly. And the dual band antenna. So you need an antenna for 2 meters and 70 centimeters that are on the same axis, because you're going to point it all together at one spot in the sky. And you can put it, you can hold it in your hand. They have a hand grip, or you can mount it on a tripod or on a rotator if you've got a very fancy setup. The rotator can rotate azimutally or through elevation as well. So you can actually program these if you get that sophisticated. I'm not doing that at this point. My goal here, my bucket list, is to include at least one contact on the satellite, which I've yet to do. Any questions there? Okay. Just a brief history. I'll try to skip most of that, but the first amateur satellites were launched in 1961, shortly after the WARC approved experimentation by satellites. In 1960, recall the first actual satellite in space that was heard by anyone was the Sputnik in 1957. So we're only 3 years after that ham radio is getting into the act and approved to launch satellites. And at this point, the satellites were not accessible with an uplink, downlink thing. They were just transmitting a beacon, essentially. This in Oscar 1 in 1961 was heard around the world, and all they were sending in Morse code was hi, hi. So people got really excited when they heard that. It was on the 2-meter band, and was heard by more than 500 hams in a bunch of countries. And notice that the satellite weighed about 4.5 kilograms, maybe 10 pounds. So it was a fair sized object to launch into space. It didn't last very long, 3 weeks. It was very low power, and the batteries in those days were not very long lasting. Oscar 3 launched 4 years later. It was over 16 kilograms, and it was the first ham satellite to relay voice, 2 meters up and down, and it lasted 18 days, and a lot of people were really excited about that. Oscar 4 in December of 1965 had 4 antennas, 3 watts of power. It weighed even more, and it was the first one, I think, to have a uplink on 2 meters and the downlink on 70 centimeters, and it operated for 85 days. So I kind of summarized a few more here. We'll post this on the website so you can look at this in a little more detail. But basically the history of satellites parallels the history of miniaturization of electronic components. As things are getting smaller, integrated circuits are being developed. They're all being used into satellites because weight is very, very important, and the size of the satellite itself causes drag. So the smaller the better, the smaller the less power it consumes, and so the longer the batteries last, and so on. And there were even at one point, I forget where it was in here, they actually started launching satellites with solar panels and rechargeable batteries and so on. So all that, the battery management, power management was just as important as everything else. And the Oscar 7, which is when you see AO 7. That stands for AMSAT Oscar. It was launched in 1974, and this month's TCA, Canadian Amateur Magazine, has an article all about it because it's celebrating the 50th anniversary of this satellite. It's actually the longest living satellite ever launched by mankind. That's still going. It's really an amazing story. I'll just take a minute to talk about it because I found it fascinating. It was launched in 74 and the battery failed in 1981. And the way it failed was a short circuit. And it stayed shorted for 21 years. But suddenly that short disappeared and it was now open, is what they figured out afterwards. And one of these guys, I think he was in England, was listening for satellites back in 1981 and heard a funny beacon coming out of this thing and recognized it was actually the Oscar 7 satellite that hadn't been heard from in 21 years. And what was happening was when it was facing the sun, the solar panels would provide enough electricity to run the computer on board, and it would boot up. And in some, there are a number of different modes, so you'd have to listen to find out which mode it was in, and then you could listen for it. And actually, you could start if it was in the FM voice mode. You could actually work somebody through the satellite while it's facing the sun and getting enough energy to power the transmitter and the whole thing. And it's still working to this day in that mode. So when it's in the dark, there's nothing. But then when it comes back into the light, it reboots again, and it's all over again. So people are still using this 50 years later. It's kind of spooky. All right, let's move on. These CubeSats are the sort of the latest thing. People are building their own, and or a lot of universities, colleges, places around the world are building little CubeSats, and they can launch a whole bunch at the same time, and for different purposes and so on. You can even buy, if you go to the AMSAT store, they're selling kits. You can build your own AMSAT kit. It's not going to be launched in space, but it's just like those that are, and it's got a Raspberry Pi in it, and it's got capabilities. But they're about $400 US. So getting started, which satellites can I work? Depends on what my equipment is. If I don't have a VHF, UHF rig that does sideband and CW, I'm not going to use those modes. If I only have FM, which is my case, then I'm going to try to find a satellite that I can do FM voice. And Sid has the capability of doing APRS with his system. We'll show you that in a little while. And so he was able to make some contacts or actually just send data through the International Space Station. So AMSAT, Amateur Satellite Group, is sort of your one-stop shop. It was formed in 1969, mainly to this day by volunteers, and their focus is on design, construction, and maintenance of satellites, ensuring public use and availability, and promoting STEM throughout the world. Also speaking with the ISS every week or so, they have a special time slot, and they publish lots of weekly bulletins and other information on their website. So if you go to the website, this is one of the tabs you can click on, and you'll see what's live. This was a few days ago, and there's a color key on all this, and those are all the satellites that had data. And so if you want to work any of these, all you do is you can click on, these are all live links, the colored numbers and whatever. The number tells you how many reports they've received recently on working that satellite. So if you work a satellite, you can actually go on that website and report that you worked it. All right. So a little bit of lingo, getting familiar with this. A lot of people refer to satellites as birds. So I'm going to work a new bird today, that kind of thing. You have to know the modes of operation, the uplink and downlink frequencies, and if there's any tone required. AOS is the acquisition of the signal. That's when you can first start seeing the satellite over the horizon. And you can have your window of opportunity to work them. And then the LOS is the loss of the signal. That means it's going down over the horizon again, out of sight till the next pass. So you need to know the azimuth. That's the like 30 degrees east of north. And the elevation, how high in the sky is it going to get up to 90 degrees. You need to know how to program your radios or radio, and you need to know where to find the prediction information. One other thing that you have to take into account is the Doppler effect. I'm sure everyone's familiar with that. So I'm not going to go into the physics of it, but when things are moving towards you, there's a frequency shift which you have to compensate for. So you program a number of frequencies into your radio so you can keep up with it. The interesting thing about the Doppler effect, it doesn't seem to be as much of a problem on 2 meters as it is on the higher frequencies, on 440. So you can leave the 2 meters all the same frequency if that's your uplink, and the receive you can change. So you program a bunch of channels in your radio for 5 kilohertz or 10 kilohertz difference on the receive. And so you can keep, as it passes by, it's going to start going down in frequency or lower frequency. Questions so far? Okay, so what would you do to get to the QSO? So there's various programs. Years ago when I tried this, they were all, or most of them were free. Now I couldn't find anything for free. So the world has changed a little bit, but the cost is not a whole lot. I think like $10 a year for some, or even less. So I haven't purchased anything yet because I haven't decided when I'm actually going to start trying to work something when it gets warmer out. So you plug in the coordinates, or you get a package that tells you when to do it. In AMSAT's website, they will predict up to the next 50 passes for you. There's no charge to use their website. If there's a beacon on the satellite, you can listen to see if you're hearing it, which is a good thing. They recommend using a headset or a boom mic or separate earphone with microphone to help out. It's kind of a juggling act when you're doing this. If you're trying to use 2 radios, point a dual band antenna, and talking to your microphone, record it all at the same time while this thing's moving across the sky, it can be pretty daunting. So you've got to get things figured out well ahead of time. I built a little arm for my on a tripod so that I can save a little bit of trouble trying to figure out what to do with the radio and so on. One thing you want to do is open the squelch all the way on your FM receiver so you can hear the weakest signals. You want to record, or either that or have a notepad so that you can write down the stations you might happen to work. And then for FM communications, you have to remember the capture effect. So the strongest signal is going to take over or capture the weaker signals. So some people actually use a little bit of power on their transmit. They get an amplifier, maybe 10, 15, 20 watts instead of the 5 watts that come out of most HTs. But there's plenty of people that say that's not necessary. You just go with it, and when it's your time, 5 watts will be plenty. Antennas. Most amateur satellites are put into low Earth orbit, or LEO. They're rarely closer than 800 kilometers when they're right above you, and about 3,000 kilometers when they're near the horizon, something like that. It gives you an idea of the range. So a little rubber ducky antenna is not going to cut it for most satellites. Maybe with the ISS, you can get away with that. The other thing I learned, I didn't realize this, was satellites are tumbling through space. So that antenna that's sticking out of the satellite is actually rotating in various planes. And so the reason for that is when a satellite is facing towards the sun, it's heating up very quickly, and when it's away from the sun, it's cooling down. So the tumbling action actually keeps the temperature inside the satellite at a reasonable uh, value, that it won't fry the electronics too badly. So they take all that into account, but that causes issues when the antenna is moving like that of polarity, or not polarity, but polarization. So you have to overcome that with a little bit of gain on your antenna if you can. And one of the best solutions for this is a handheld Yagi antenna. So this is what the arrow antenna looks like. The longer, there's 3 elements on 2 meters. Those would be the near vertical ones, and then the other ones that you can see with the orange ends on there. There's 7 elements for 440 megahertz, and so it's all on the same stick. And so there's 2 different connectors, BNCs. And so, of course, you have to have adapters to go from BNC to whatever your transceiver has, typically SMA these days. And you have this little diplexer that mine came with when I bought it at a flea market. And so that diplexer has a filter that goes from, basically, it allows 2 meters to go through on one side and 440 on the other side. If you don't want to have one of those, there are other options. These omnidirectional antennas, there's 2 full wave loops 90 degrees out of phase with each other, and some parasitic reflector elements to provide a little gain at the base. So you don't have to point it at the satellite. You just mount it, and then you can have your station inside it in your shack and hope for the best as the satellite flies overhead. It's called an egg beater. And there's other ones as well, which we won't go into. So I pulled this up. This is from the AMSAT website, and the FM repeater satellites posted 5 of them, and then the other ones, the transponder satellites, typically sideband, CW, or digital modes. There are a lot more to choose from, but many were not accessible at a given time. So again, you can plan ahead and see what you can do. The XW2B is apparently fairly accessible from here. The Saudi Sat, this has been going for quite some time. It's one of the more reliable and one of the few FM repeater satellites. Uplink is 145.85 megahertz, and downlink, you can see that there. To activate this, you need a 74 hertz or 74.4 hertz tone. It gives you a 10-minute activation window if someone hasn't already activated it. And then while you're transmitting, you need to have a 67 hertz tone. So there's some examples of how you would go about programming your transceiver for the Doppler shifts. Notice the transmit doesn't change frequency, the receiver does, because it's on the higher frequency, the 440s. So I've got this FT60. It's a dual band radio. There's many others you can choose from. Plus I've got the little mic, plug-in mic and speaker. So that can free up my hands a little bit. there's a clip on the back of the transceiver that goes on the cradle that I made, so that I just have to hold the microphone speaker, and rather than the whole radio itself. And this is the setup. Now the Arrow antenna is basically, it comes with a little mount for a tripod, so it's got a screw mount hole. I just took a piece of a right angle aluminum and mounted it on there with a couple screws, and then I took some other aluminum and I built a little cradle for the iPhone and the rig to sit on there. So the iPhone, I can use it to, if I have the app downloaded, I can follow the trajectory directly with that and know how to point the antenna. Or I can also use it for recording, audio recording. So that's kind of the setup, and you would follow that. Now, you would not use it necessarily in your garage, but it was snowing when I took the picture. But you would follow it around the sky, so you'd want to be in a place where you have a clear path to where the satellite's going to be. So I found 3 possible satellites to work. One is the space station with the uplink, downlink frequencies, the Pocket Cube satellite from the UK, and the Saudi sat. Unfortunately, right now, most of these are flying over us at about 3 o'clock in the morning, which is not terribly appealing to me. So I think I'll wait a little while. We'll get into that. And this is programming the HT. I use Chirp. If you're not familiar with that, it's a free program that can program a lot of these things. You just need a cable that goes into the audio jack of your HT, and it has a USB connector on the end with a little adapter for the digital tones on your USB. So it's the cable is I don't know how much they are these days. Had it for a while, but you can then program it without having to program it manually. You program it in the computer and just download it into your HT. So here I'm showing that on the left side you've got your receive frequencies. On your right side, or sorry, in the middle, you've got transmit frequencies and the necessary tones. The nice thing about this satellite 124, SO 124, is it doesn't require any PL tone. So this is showing that you're using a split frequency where basically you're transmitting on one frequency and receiving on another, actually one band, and receiving on another band. So when you go to AMSET and you want to work the ISS, one of the displays, you can see where it's going at that very time, where its path is. And then you can look up to the next 50 passes. And so I looked this up March 6th. There are 2 passes that I thought might do, and another 2 on March 7th. And I just plotted them out. I got this compass graphic. I just copied and pasted that onto this page, and then I overlaid like the red, green, blue, and purple paths. And so you see that, for example, path A, March 6th, it starts at the acquisition of signal, 08:33. This was before we went to daylight savings, so I'd have to subtract 7 hours. That'd be 1:33:58 in the morning. And then it's going to last 10 minutes and 56 seconds. And then the azimuth that it comes over the horizon is 265 degrees, which would be where the red starts here. And then it's going to go all the way to where I lose it at 85 degrees. So that red arrow shows basically the path that it's going to follow. And I've done the same for the other 4 paths. And so they all start out at the west. They all go to the east. And the highest is why I chose these. I wanted to get a maximum elevation as high as possible. 82 degrees, 78 degrees. And here is close to 90 degrees, like right overhead. So you would try to follow this and give yourself a chance, probably the best chance when it gets very high in the sky. So, and the only thing you need to do to get these output is you can put in your grid square. It calculates the position, and then you put your elevation in as well. And then hit the predict button, and these come out. So this is an example. If you want to look at a website, there's a YouTube video, and this guy actually, W1FRD, is a couple of years old, but he just does this from the side of his garage. And you can see he's using 2 radios and the headset, because he's actually listening while he's talking here as well. And so and here he doesn't need a diplexer, because each one he's feeding in the antennas separately. And here's for the Hades R, or SO124. I found one. March 13th is coming up, and it will be at 1906. We'll start to go over the horizon, so I subtract 6 now. 13, that's 1:06 in the afternoon, or 1 p.m. So I might actually try this one, and it gets up to a maximum elevation of 75 degrees. So it's going to start up here and go across the sky, and the maximum elevation is going to take place at an azimuth of 276 degrees, so pointing almost due west. So that's how I have to follow it over the path. And at that time, I calculated half of the path duration. So at 1913, which is 13:13, or almost a quarter after 1 in the afternoon, it'll be at the maximum elevation. So making the QSO, make sure your squelch is wide open. Use a compass, or your smartphone with a compass on it, a compass app, to guide you. Continue adjusting the antenna direction, orientation, until you hear the signal. Activate your recording device. You don't want to miss who you talk to if you do succeed. You can, if you hear somebody talking and calling CQ or QRZ, right away give your call sign and your grid square. So I just say V6TLD021. And or I could wait. If I'm hearing somebody talk after they're finished with somebody, I just give my call sign and grid square. And remember Doppler shifts if I start to lose the signal. And good luck. That's what I'm hoping to do. There are awards. There's an award to any operator for having made their first contact. So that would be nice. Also, if you make 20 contacts on any satellite, you can get a Communication Achievement Award. There's also RAC has an award for working all 13 Canadian call areas. If you really get into it, worked all states, even a DXCC endorsement for satellites. So some people are really into this. And some breaking news today, I just learned that Elon Musk is saying that the International Space Station has basically served its purpose, and he wants to cut it short. In other words, you've only got as much as 2 years left to work anything through the space station. The FM repeater and APRS digiteer will be no longer available after 2027, instead of the normal scheduled retirement 2030. So of course, NASA and other folks are very upset about this, and they're trying to see that they can extend this to honor their agreements that are to 2030. So if you're going to work satellites, you've got to work within the next 2 years, or work the ISS, I should say. So as a summary, what do you need to get started? You need a amateur radio certificate. You need some kind of antenna. You need some kind of either one radio or two that can work 2 meters, 70 centimeters. you need to download or look at the website to predict which satellites you want to work or you're able to work. There are apps for your smartphone that show you direction, compass app, and it helps to have a speaker microphone, but not absolutely necessary. All right, so now we have a presentation from Sid that he's asked me to give as well, real quick. This is a very short, but it shows you what you can do even with limited equipment. Everyone seeing this? This is a little index of for what you're going to see. And basically what Sid did was he used APRS, which uses 1200 baud rate audio frequency shift keying FM to send the data. And he wanted to send basically a message of interest, his position, a short message, and an email address. So the protocol that he used also allows for weather and other information, APRS. He just wanted to see that he could get it to work without anything too fancy. So this is Sid's very sophisticated setup here. He's got basically a Baofeng handheld transceiver, which is on the bed, an older Android phone, and a quarter wave mag mount antenna located conveniently by the window. So basically the setup is his cell phone connects to the radio using an audio cable, and he sets it up using Vox1 or Vox enabled, which is the voice operated relay, and Squelch1, most sensitive squelch setting, and it transmits 5 watts in theory. Okay, and on the Android phone, he used an app called APRS Droid, which I believe a lot of people have familiarity with. And after you set it up, you have to get the passcode and all that. You connect it up as an audio type music. All right, this is so you get all the frequencies that you need, and then you set it up. The digipath is set up for the Calgary digipeater through RYC. So the idea is to first test out that this thing is working through the local repeater, RYC, and then if that's working, then let's go for the satellite. And then, so once this arrow here is displayed, then you can send an SMS message to this address using this protocol here, where the X's are your phone number and your Y's are the message. And you send an email to email to, and followed by a space and then the message. So there's 2 ways of messaging here, the SMS and the email. So this is, for those who haven't seen where the RYC repeater is, it's on Nose Hill. I did this from Google Earth and just zoomed in here and made a little picture of it. So before, like I said, before contacting the space station, Sid contacted RYC and sent his position and email through RYC. And oh, sorry, that got put in the wrong spot. All right, so anyway, so doing the ISS, the frequency was different, of course, than the RYC repeater, so he set that properly. And you don't have to worry if you're on 2 meters about the Doppler effect, because you're just uploading it or uplinking. And he had to wait for a pass where it went conveniently past his south-facing window. So he actually went on the AMSAT website, just like I was showing you before. And this was at the start of acquisition of the signal was at 10:55 or 10:56 almost UTC. So say 11 11 a.m. is -7 at the time. It's 4 in the morning. So we'll have to check to see how Sid's sleeping patterns are. But anyway, he managed to get up or stay up for this and work the thing. And once he was successful, you could see that it reported basically APRS thru ISS, which is the Russian astronaut's call sign, I believe. And there it was posting on the APRS.FI website. And if you go on the ARISS.net website, which is for the space station, you can actually see that it posted SIDS V XYD-7 on the map. He said he couldn't expand the map. That's what you get. So he had immediate confirmation that they had heard him. And then it showed also on here that his latitude, longitude, and how many minutes ago he had actually contacted the ISS. All right, and then the subsequent pass, on a subsequent pass on another day where he still couldn't sleep, he was able to send email through it, and they tracked it down, and the message was email through ISS, and there's a list of stations that sent email, and there it is, email through ISS. He was able to actually track it down and see what the email was. And you can see stations from all over, B5, KB6, so all over the place near him in time for accessing and sending emails as well. So that's it for these presentations. Sid is here to answer questions on doing it digitally. I think you've got a lot more satellites that are accessible through the digital modes than FM voice. So that may be something, and I've got a radio that does APRS without having to attach anything to it. So that's something else I need to figure out how to do as well. Okay, so I'm going to and open it up for any questions. Has anyone, I'll ask a question if I may, has anyone here actually made a satellite contact?
Actually, there used to be a group here in Calgary. There's myself, Ken Oakey, Lindsay, Brian Jackson, and we used to schedule links with the astronauts on the ISS and downlink them into usually elementary, junior high schools and that around the city. And that we probably had about a half a dozen radio contacts. And then Brian and I set up about 20 telephone contacts through another station into the ISS and that. So, like I say, there was a group. They're probably still around. The equipment is still around if anybody's interested in resurrecting the group and that. But a lot of fun, a lot of stress, but just a really interesting, a few projects in that of setting up a full uplink and downlink. It had to be coordinated through both NASA and through the Canadian Space Agency to get it done in that. So a lot of fun and that. But yeah, there was probably about 10 of us. And we had all the equipment, the tracking, the radios and sound systems and everything. It was basically a turnkey. We showed up, set it up, and had a lot of fun.
So when you were tracking, was this that was, I assume, a rotator that could track the satellites azimuthally and elevation-wise? It would.
Yeah, full ASL, computer controlled.
And was it a parabolic dish or?
No, it was two crossband, a UHF and a VHF crossed Yagis and that.
And I take it the ISS has a pretty powerful transmitter, so you didn't have to worry about fading.
They actually had a couple. One was a Pi, and the other was a Kenwood that they were using, but basically just consumer ham radio. Nothing really fancy in that. Probably 20 watts and everything.
That's a lot of power.
Yeah. One thing I will mention for anybody who's trying to do contacts with satellites and that, if you can get a north-south pass, you get to talk to the repeater first before the Americans pick it up. Because once it's in sight of a lot of the U.S. stations, it's just pretty well overwhelmed with the traffic and everything. But if you can get a pass from the north to the south, you've got 5 or 10 minutes where there's not as much traffic and that on there. Makes it a lot easier to pick it up, especially if you're just beginning.
So if you're pointed towards the north, don't you have to have somebody even further north to talk to?
There will be, in a lot of cases, you'll get, some Europeans or maybe, like I say, somebody in Canada and that, get it. For anybody who's interested that doesn't have the equipment right now, and I haven't been to the site for a while, but Kara has a pretty good ASL tracking antenna radio and that is available. Or it was a few years ago anyway. I don't know what the status of it is now, but just so you don't have to go through all the hassle of building your own and learning, there was a really good system there that worked quite well.
Thank you, Jerry. Other questions, comments?
A point that Jerry is making, a transponder has a certain bandwidth and it's total power in, total power out. So if somebody blasts a pile of power up, then they get all the power out of it within that bandwidth. So it's kind of gentlemanly that you don't fire like a kilowatt at it, but it is a competition thing. That's right, which is kind of weird as well. So. And I was going to briefly mention that I don't know if I can, there's an article in QST if you want to build an antenna. And if I can, yeah, I don't know if that's coming through. It's a QST article from May 2008, and it's a way to construct a 440 and 2 meter and put your handheld right on the thing, which is one way to do it. But as Jerry says, why the heck borrow it and play with it in the club? Another thing I found that might be really useful, there's an app that on the iPad, and it might be available on the cell phone. And it has both elevation as well as compass, which is kind of cool. So, and you can even look through it as a camera. So you can look your camera right through it. So it's a transparent thing. So you could pick a point on the horizon and actually say, okay, kind of look at the rooftops or whatever, so you can get an idea of the elevation you should be tracking. So it's called Commander Compass. You might look for that app, which is quite cool.
I seem to recall years ago when I downloaded a free app that on my iPhone that it actually did that, as lined up the satellite for you. So I don't know if those are still available or not, but there are a number of apps on the various, I guess, the Android and the Apple stores to do that. I haven't seen any free ones though, but with that information from AMSAT, you should be able to get pretty close. Try, I think beforehand, just to trace out the arc in the sky a few times to see what you think it's going to look like. Make sure you've got a clear path.
I've been able to hear communications on the satellites, and I tried calling up once and didn't work. I probably had something wrong, but I can hear them.
Oh, it's more than I've done.
I have a question that I'm sort of confused about. The antennas, the cross-polarized antennas where the high frequency and the lower frequency are 90 degrees from each other.
Mhm.
Makes sense. Is that how the antennas are on the satellites? And then secondly, if they're tumbling, does that continually change? And are you kind of rotating that to try and find the polarization when you're talking to it with the handheld antenna?
Yeah, it's a good question. The best I understand, or I looked into that myself, is that if you have enough gain, yes, the antennas are going to be tumbling and rotating, whatever. So changing the polarization, so there'll be a certain amount of fading as they go out of phase with your antenna. But if you have enough gain, you can usually still hear them through the fades and it's happening quickly enough that it won't really affect the communication that much.
There are also turnstile antennas that are basically right-hand circular. So it gives you the combination of both polarization. So that mitigates the fading a lot. So that's another recommended. I noticed one of those that you showed, Jerry, said that the combination of the two of them would result in a bit of right-hand circular, which is good for the tumbling satellite. So yeah, that's a very interesting thing, Pat.
I was just going to ask Sid if he's got any more comments about his presentation.
No, you covered it very well. Thanks.
Thank you for that. Niru, sorry for interrupting.
No, that's okay. I had a question about the egg beater antenna. It's if I remember correctly, it's a full wave. Is that right? Is it only one frequency?
Yes.
So you'd need a separate antenna for or do you need two of them? How do you receive and transmit?
I believe that was mainly transmit antenna.
Okay, so you need a separate one for receive then.
I think so.
Nero, do you want me to do a QST search and see what I can find? I've got a bit of stuff in my library on that, but I could dig some
Sure.
stuff out of it.
Yeah, sure. Thanks. That'd be great. Thank you.
Okay.
That's a good point because that was a mono frequency, a single band antenna. And I believe the only reason you'd want that much gain is for the transmit.
And don't forget the idea of disc cone antennas. I've got a couple that I've got to rebuild, and they're like zero gain. They're no gain at all. But disc cone antennas are extremely wideband, and they're great for initial listening. So yeah, that would be a great way to start. Like as Nero said, do some listening first and see what you can hear. That's got to be before you start transmitting. You got to kind of let's track this thing across the sky and get the feel of it, right?
Yeah, maybe we could make that a pop-up event sometime when it's a little warmer, maybe not so much snow on the ground, but say May-ish. I wouldn't mind getting together. It depends a lot on the passes and the time of day, but it might be fun to just try. Who knows, we might make a contact.
Yeah, from fox hunts to bird hunts.
Yep. Do something.
Sounds good. And also try a voice and a data.
And Jerry, just a note on your presentation on the opening there, one of the satellites that you admitted was Sputnik that did beacon in the amateur band.
Right.
That was 57, I believe, right?
Yeah, I did mention it. I didn't have it documented there, but yeah, it was the first one that was at a first beacon, first satellite up, many of them, but it wasn't an amateur satellite.
No,
and it was heard at SAIT by a fellow I'm going to have coffee with on Wednesday, Brian McBride, first technician at SAIT of V6XL at the time, and he had Helicopter Skyrider, and he recorded the beeps on the Sputnik in 1957. So there's some SAIT history. And another cool piece of SAIT history is that a guy by the name of Sol Fleury had a circular polarized antenna system and sent pictures, the weather facts from the NOAA satellite I think the very first broadcast, Jerry, you'd smile at this one. The very first broadcast pictures, I think, were sent to Don Wood at CFCN. And so first broadcast weather satellite photos were, I think, in Calgary, kind of cool. And my boss had actually a tracker, beautiful Azell rotator system. I know that probably got thrown away on the roof of that building. Gorgeous thing. And another thing that I was able to do is the Alouette satellite at SAIT. They had an Earth station there, so I was able to talk to myself up and down when Alouette first came in here. So that was the first commercial satellite too. So some bizarre history in Calgary.
Very good. Well, I hope this has given people a little flavor for what's involved. It's not all that complicated, but you've got to do some planning, and hopefully, like Nira says, we can get together as a group, whoever's interested, and try to do it. I think we should probably try to track down at the club. I'll put this on Brett's plate maybe to see if there's any equipment still there to do this, and if it's available or whatever. So I'm sure Rob would probably know. He's probably the guy most likely to have an idea on that. But that sounds interesting. And if it's still available, I guess what you put, Jerry, you put in the Keplerian parameters, and it will track from there.
Yeah, just update the KEP files on the computer that's controlling the Azell rotor, and basically, yeah, pick the satellite you want, the pass, and away you go.
How do you know? How do you calibrate the rotator?
Basically, just a compass and your readout, the telemetry that comes back from it, and then into the computer, and that. So they all have to match, both mechanical and the electrical status back from it.
Okay.
And it's not like a half a degree is going to make a difference. It's not like geosynchronous satellites or anything like that. Like I say, you from using a handheld antenna, and that you can be anywhere in the ballpark and get a pretty good signal in that.
Very good. Okay, well, we're kind of running a little over time, but I just want to see if there's any more questions, any more comments on what you've seen tonight on either presentation.